accurate. That depending on your time constant. If you say, okay, my time constant is 0.1 second, you tell your boss, okay, after 0.1 second, you can count out the sensor. Is that correct? No, because it's only 63.2%. If you say, okay, we know it's going to be close to 1 as time equals to infinity, you can tell your boss, after 2 hours, you can use the number, yeah, for sure. And you're going to be fired because nobody will wait for 2 hours. Right? But if we know this is going to be 95% or 98% or 99%, which one are you going to choose? You can tell your boss, okay, after 0.3 seconds, after 0.4 seconds, or after 0.5 seconds. Which one is the best one? 3T? 4T? 5T? The answer is either this one or this one. You're going to find in your textbook. Most of the people will use 3T because 95% we can accept that. 98% is good. And between this one is not so bad. But after you went for another time constant, the improvement is only 1%. So some people use 5T, but not a lot. Most of people will say, okay, after four time constants, I can start to use the sensor because it has achieved 98% of the steady state output. So in the control theory, we always use this one. When we say we want to achieve time steady state, in many, well, not many, in more than 50% of your textbook is going to use 4T. Some of the textbook is going to use 3T. So there is no correct or wrong for this part of things. You can use either 3T or 4T. When I give you guys design criteria in the test, I'll be specific, whether it's going to be 2% error or 5% error. If I'm telling you 5% error, then use 3 time constant. If I'm telling you use 2% error, then it's going to be 4T. Does that make sense? You would need to understand, when you look at the first order system, how the transient response is going to look like. Why do we want to define the time constant? When we say it's 1T, 2T, 3T, and 4T, physically, what does that mean? If you need to use a sensor, how are you going to read your sensor? Because every time you just get the plot like this, you would need to know how to read this kind of diagram based on the time constant. Sometimes the system, the specification won't tell you steady state time. It just tells you the time constant. Can you use the time constant directly? No, because you need to multiply that either by 3 or 4. And you need, when you design your controller, you need to wait at this 3 or 4 time constant before you can start to read the data. Is that clear? Everybody understand what I'm talking about? Does that make sense? Okay, I think it's time.